So today we're going to cover lesson 8.1, graphing exponential functions. So here's your title page. And here we have some notes. First of all, what an asymptote is, and then a little information about the parent function for an exponential equation. And then this bottom section, you don't need to write all of this down if you are adding it to the back of your notebook. In the back of your notebooks, we already have a lot of these transformation of functions, and they follow the same rules. So all you need to write down is this function, and we should probably label it. So we'll label this exponential functions. And then just draw a quick sketch of a graph with it as well. Put that down here. And our graph is that it approaches the x-axis over here, doesn't ever touch it, and then swings up. And then some other notes. These you do need to write down. So this is an exponential decay function. And notice here, b needs to be between 0 and 1. So that would mean that it's like a decimal, like 0.5 or 3/4. It could be a fractional expression of it. And then some notes that you've taken in 9th grade, but I think that you've probably forgotten, is our exponential growth formula and our exponential decay formulas. So these are all notes that you need to copy down. And then let's get started on the examples. So here's our first example. Take a second to copy down the table, and you will need graph paper. So now what we can do is we can insert these numbers in for x. Okay, so let's just think about what this would be. 4 raised to the negative 2. Well, we know that a negative exponent means 1 over 4 squared, so that's really 1/16. How about negative 1? 4 raised to the negative 1 is 1 over 4 to the 1 power. That's 1/4. 4 to the 0. Anything raised to the 0 power is always going to be 1. And then 4 to the 1 is just 4. 4 squared is 16. Okay, let's plot these points. So go to your graph paper, draw an x and y axis. And really, we don't have any negative y values, so you didn't really need to make that part of it. But let's plot the points. And at negative 2, it's 1/16. So it's very close to the x-axis, but it is not touching it. Negative 1 is 1/4. 0 is 1. 1 is 4. And 2 goes off the page, so that's up here somewhere. So when you draw this graph in, you get really close to the x-axis, but you do not actually touch it. And then you go up. So there's our graph. Now the domain and the range. So domain is x, range is y. Domain, we think about a line going through this way. When is the line touching the graph? It's obviously touching it there, but what about over here? Is it touching? Eventually it will. It's going to touch way at the top. So it will always touch. So rather than saying x here, we can just put all real numbers. Range goes the other way. When is this line touching the graph? It obviously is up here, but at 0 it is not touching, and then below. It gets infinitely close to 0, but it never touches 0. So the range is when y is greater than 0, but not equal to 0, so we don't add that extra line to it. All right, next slide. So this one has a little bit of a difference to it. It has the -2. Okay, so let's speed things up a little bit. Let's pull out your calculators and type it in that way. Now in your calculator, you're going to go to your y equals and type this in. Some of you will need to go y equals 3 raised to x minus 2. And since the x is the only thing that's as an exponent, we don't really need parentheses. Now if your calculator is like mine, where it raises it to the x, we'll type in 3 raised to x, you have to press the over key to come back down a couple times, then minus 2. Okay, let's go look at a table. Second graph. If your table's not set up like this one, you can press second window, and then you can tell it what to start at. I'm going to just change mine to start at -3, so it's all set. And then those are my values that I need to write down. So -1.963, that's already there. And then we'll copy down the rest of them. So I took a little picture so that I can see it, and we'll just copy these down. Okay, then let's graph it. So I'm going to start by drawing my x and y axis again. I'm going to bring it down just a little lower this time. It doesn't really matter. I'm not going to fit 25 on here, I guess, either way. That'll be good enough. Okay, so I go to -3. And now notice I'm actually below the x-axis this time. Almost down to -2. At -2, I'm still down there pretty close to -2. 1, I'm starting to come up a little bit. At 0, -1, 1 is 1. Now I'm really going up. So at this time, my asymptote is right here at -2. So it approaches -2, but it never touches -2. So the domain for this one again, think about this line going across. It's always going to be touching, so it's going to be all real numbers. For exponential functions, the domain is always going to be all real numbers. The range, though, is not. The range has to be greater than its asymptote, because the asymptote's going along right here at -2, and it doesn't touch there, but everywhere above there it touches. So you say y is greater than -2. Okay, let's try this one. What happens if we have that -1 up in the exponent? So let's go back to your calculator and type that in. Now this time you want to make sure that it's written up there. Now if you don't have a calculator like this, if your calculator says 2 and then it uses the raised to, you must put parentheses around the entire exponent because it's got multiple parts to it. Otherwise it only raises it to the x, and it would think that it's 2 raised to x minus 1, and that's not correct. So we've got this. Look at our table, second graph, and we can copy those down. So go ahead and hit pause and get those copied down. And so there's our table. Now we're going to graph it. Draw your x and y axis, and we'll plot the points. -3, it is very, very close to 0. -2, still is pretty close to 0. -1, it's up about a quarter. At 0, it's only up half. At 1, it's finally up 1 whole block. 2 is 2. 3 is 4. So this time our asymptote is again at 0. And if we connect them, it shoots up like that. So domain is all real numbers again. The range, though, y is greater than our asymptote at 0. So it's always above this line right here. So y is greater than or not equal to, just greater than 0. Okay, let's move on to a real world problem. So we've got a bunch of people in the world in 2006 using the internet. So it's growing by 19.5% annually. Draw a graph showing how the number of users could grow from 2006 to 2016 if that rate were to continue. Well, we need to go back to our slide back here that tells us our equation. So we start with our initial amount, 1 plus our rate raised to t. So coming back here, we say our initial amount is this 1,020,000,000 times 1 plus our rate because it's increasing. If it was decreasing, we'd do minus. But we need to do our rate as a decimal, so you would divide that by 100. So it'd be 0.195 raised to t. Okay, that's what we're going to be graphing. So let's put this into our calculator. Go to your y equals and type that in. And by magic of the pause button, I have it entered in. So if you haven't done so, press pause and then type it in. Then we can look at our table. Now at your table, it's probably going to end up like this, yep, with a bunch of e's. If you scroll over, then you can see the exact numbers. And what we're looking for is from 0 up to 10, because it says here we are starting at 2006 and ending at 2016. So 0 is 2006. So I'm going to scroll this or start this at 0. So I did second window there, and now I go back to second graph. And I'm going to jot these numbers down. So there's my starting point, and it's gradually going up. So in 2010, it's going to be, what is that? Just a second here. Okay, so I had found out that I'd forgotten a 0, so that's why my numbers were looking a little funny. Okay, now it looks like in 2010 it's going to be 6 billion, over 6 billion. So if we wanted to graph this, we're going to need to do a scale here. Draw my x and y axis. And I decided to change them a little bit. Okay, so if we are going up by a couple billion, we should maybe just label it as 1 billion, 2 billion, 3 billion, and so on. So 1, 2, 3. And again, by the magic of the pause button, I've labeled it. And then let's go by ones on our x-axis as well. And so I've got those labeled. Those are our years. And now I've copied some of the screenshots over. And now we're just going to plot those points. So this first number would just be at about 1. The second number is at just a little bit above 1. And so on. We're going to plot all of those points. So you might want to hit pause so that you can get your points plotted as well. But there's our points. And there's our graph. Okay, let's see what a graph looks like if we have a fraction. So again, go to your y equals and type this in. I'm going to hit pause, so you can hit pause as well to do that. And the parentheses are important, so make sure you're including those. But then I look at my table, and I can copy these numbers down. So again, you can hit pause so you can get them copied down. But as I do that, I realize they're actually going up by a half step, or at least on some of them. So let's go to second window and change our table set to go up by 0.5s rather than 1. So I press second window to get there, and now you go back to second graph. And so we've got those. And then we can plot those as well. So again, I'm going to hit pause. You can do the same, so you can plot them on your graph paper. And these are the points that we can plot. We can't plot very many of them, but the graph is coming along like this. So it has reflected it along the y-axis. Our domain is still all real numbers, and our range is still greater than our asymptote. So it is y is greater than 0, but never touches 0. Okay, let's take a look at an air pressure problem. So here we have a starting air pressure of this on Earth's surface. But as you go up in altitude, it decreases 20% for every 50 miles. Estimate the pressure of altitude for up to 50 miles, not 20% for every 50 miles. But estimate it for 10 miles. So what we're going to need to do is write our equation, our starting point, times 1 minus 20% as a decimal, raised to 10. And if you type that into your calculator, you're going to end up getting the answer 1.6 approximately pounds per square inch at an altitude of 10. Okay, that's the end of the lesson. You can write your questions and summaries.